and the activities which are carried out by the researchers. So today's talk is on overview of defense and space technologies and research funding opportunities in this domain. Probably the pictures included in this opening slide, they are indicative of two domains. One is the defense and the other is space. Now, if you just look at the importance or interest related to research, then we see that there is a charm, challenge, excitement, and satisfaction in conducting research. All the teachers, they are always looking forward for doing something new, and for doing that they need some kind of support, some kind of help, some kind of excitement, some kind of motivation, and that is all provided by various kinds of research opportunities. They have their own research interests, and this research interest essentially drives them further to conduct some kind of research. Research is an endeavor to discover answers to intellectual and practical problems through the application of scientific method. It's a cornerstone of building a case or a story to understand a phenomena, situation, or behavior, to expand knowledge of a chosen field, to develop critical thinking and analytical skills through hands-on learning, to find answer for how, what, which, when, and why about a phenomena, behavior, or a situation, to test existing theories and to develop new theories on the basis of existing ones. Research is also conducted to develop one-on-one connections with distinguished faculty in their field. And that's what we are essentially trying to achieve through these kinds of sessions. We realize that defense and space research, especially, is filled with excitement and sense of fulfillment always. Newer and challenging fields of research are open for youngsters and scientists. Opportunities are waiting for potential researchers. All such kinds of pictures whatsoever are seen on the screen, they are every now and then exciting us always. Some of them are at the Republican Day parade, some of them movies, some of them on the television, and we see that the laboratories at different places, which are called as centers of excellence. There are say things like the guns which are firing various kinds of uh, missiles and rockets and so on. So these are all exciting fields. Yes, apart from the excitement, there is the importance associated with the research and development in the defense and space research program. That is related to the sense of responsibility, the kind of accuracy, the kind of endurance through which the research outcomes have to go through, and so on. So we essentially, therefore, as a researcher, we have to just be standing out. We have to essentially come out of our own shadows of past, and become a singular individual who is leading from front, who is separated from a group, because the groups are there, they are essentially trying to do something here and there, and many a times those are the activities which are said to be mediocre activities. But here in the domains of space and research, defense, the need is to stand out. It has to excel, it has to be a distinguished personality, and therefore the research activities are to be done. It is not just also ran type of thing. It is here essentially we have to prove our mettle. So we see that Indian Space Research is a program which is carried out by the ISRO, and this is an example which is set globally, because initially the space was the field which was dominated by Russian and American scientists. Subsequently, some other countries also joined, including China, Japan, and France. They also joined the space research programs, but they were working in isolation, so to say, and probably they had the sense of superiority. Many a times, the Indians were denied any opportunity to work in such research field. However, when the Indian government decided that there will be a space research conducted in the country, so there were organizations like ISRO evolved, and ISRO was initially led by stalwarts in the field like Vikram Sarabhai. He was the initiator or the father of the space science program in the country. The primary objective of Indian Space Research Program is to harness the advanced research areas of space science and technology for national development and to derive maximum benefit for the people of India. There is always a kind of argument that space research is done for the places where probably large population will never get an opportunity to visit. Say if somebody says that last year's success of Chandrayaan-3 landing on moon, it is basically something landed on the moon. We saw that on television, everybody got excited. But where is the opportunity for 140 plus crore people to go to moon and find out what is happening? Yes, that opportunity is not there, but the excitement of getting connected to such programs through saying that it is an Indian success, indigenous program it is, that is most important. And what is more important for the Indian Space Research Organization, ISRO, is that there were opportunities which were deprived by the countries like America with various kinds of bans and various kinds of say embargoes, that they even did not give components or various kinds of parts of various resources which are required. And in spite of that, in spite of such denials, Indian scientists did not get demotivated. They were actually motivated further, and they developed their own technologies, they developed their own research activities, their own implements to such extent that a few years prior, say maybe 5 or 6 years back, there were in a particular launch, satellite launch, in a particular launch, there were more than 100 satellites which were launched by India, out of which about 84 were from United States. So it is not just that we were flying our own satellites, we were conducting research related to the satellite and technology related to the satellites, but it is actually for the world. The various other countries we are helping, their satellites are being flown and so on. So Indian Space Research Program includes the following major elements: demonstration of feasibility of deriving from space science and technology applications in space communication, long distance education, earth resource mapping, survey, meteorology, and geodesy. Development of indigenous capability for design and development of orbiting satellites for scientific research and space applications, sounding rockets, and satellite launch vehicles. So we can see that there is a satellite launch vehicle. In fact, a series of satellite launch vehicles that was developed over the years. Some included the fossil fuel or early fuels, but later on, in fact, after the denial of the fuel, the cryo engines were developed indigenously. So some help was there available from Russia, but indigenous development of cryo machinery, that was essentially one of the major achievements, and which ultimately is now seeing that there are successful missions like Chandrayaan mission or Mangalyaan mission, or for that matter Aditya, and we are looking forward for various further missions, including Gaganyaan, which basically is a human space mission. Indian Space Program encompasses research in multiple areas like astronomy, astrophysics, planetary and earth science, Means it is not just related to developing the equipment or developing the technologies, but actually the furtherance of science in these various domains, that is equally important. Atmospheric sciences, theoretical physics supported by scientific balloons, sounding rockets, space platforms, and ground-based facilities. Starting from sounding rockets experiment for studies of upper atmosphere, ISRO has developed the technology for various launch vehicles, satellites, and payloads over the next 6 decades. That was early 1960s. The sounding rockets were used for the early research, but subsequently in the next 6 decades, the ISRO's achievements, uh, they were really touching the skies. The saga is continuing with scientific missions like ASTROSAT. ASTROSAT is basically a specific satellite used for astronomical missions, Mars mission, Chandrayaan mission, followed by solar Adityayan missions and so on. So this is the ASTROSAT, which was basically we can see that there is a satellite in the middle, and the sides are naturally the solar panels which are providing the energy to the satellites in the space. The India's ASTROSAT MEX are rare discoveries. This is the first detection of FUV photons from Lyman alpha emitting galaxy. Basically for various kinds of astronomical phenomena, observing it, because if we try to observe the astronomical phenomena through the Earth situated laboratories, then there are hurdles, because the Earth's atmosphere essentially is a major problem where a lot of things get absorbed, a lot of things get scattered, deviated, and so on. So naturally, for the minute observations, we need a laboratory, or we need an equipment which is situated outside. Various countries, they have their plans. Globally, there are things like Hubble telescope and so on. So the ASTROSAT is performing its bit in this particular galaxy. There are number of users across the country, and in fact beyond country also, for that matter, for the ASTROSAT data. This basically, we need to say that this is not the research in space science or space technology. This is the research in fundamental science, and the fundamental science research is conducted at various places in different parts of the country, globally also, and these essentially are facilitated by availability of things like ASTROSAT. Chandrayaan and Mangalyaan missions, we know that all the details, all the stories, they are around and everybody has gone through them. We see that there is a lander, what was called as Vikram lander, in the memory of Vikram Sarabhai, founder of ISRO. And then there is a rover. This is basically after appropriate landing, soft landing. In fact, this is very important and interesting to have this soft landing. The earlier Chandrayaan mission, Chandrayaan 2, failed to perform this particular last step. Otherwise, the entire mission was successful. But the last step probably somehow was missed. And in fact, the learning was done through that miss. Lot of changes, lot of corrections were made, and the Chandrayaan 3 was made successful. And the rover also moved across Pragyan, and it performed certain surveys of the moon surface, lunar surface. The concept of launching, this is 100% indigenous. For the first time, this has been used for the satellite, for the space missions. Earlier, people used to try directing it towards the particular celestial object, say moon. So there was a large thrust required. Whereas here, the large thrust at one go is not required. It is basically orbiting and making use of the gravity of Earth and the moon, or in the other mission, it was the Mars. So making use of the gravity and little small thrusters, the small thruster rockets, they were there. They were used for changing the orbit and finally reaching the escape velocity after a few orbiting, and then going again and getting it trapped within the gravity of the planet where it is mission. The Chandrayaan module comprised of essentially these two main parts. One is the propulsion module, the other is the lander module. The propulsion module is put into the orbit, and then after that the propulsion helped lander to get ejected, and then this was finally landed on the moon. But while landing there were lots of care taken, lots of control systems they were working, lots of programs they were actually made to work, and that's how the soft landing was effected. After the soft landing, the rover was rolled out and then it was released on the moon surface. Why I'm showing all this is essentially to get you excited about what all things the ISRO and defense actually is engaged in. The missions which are carried out so far, they have yielded and continue to provide valuable scientific data and are contributing to the global knowledge base for the cosmos. Just I mentioned that Chandrayaan 2 partly failed. Still, it has helped in getting Chandrayaan 3 successful. The reason is that though the lander of Chandrayaan 2 failed, the orbiter was orbiting and it is still orbiting. That orbiting device which was there, that provided a lot of data for the Chandrayaan 3 mission, and in fact it was basically the coordination of Chandrayaan 3 with the Chandrayaan 2 orbiter that has helped in getting the landing successful. Similarly, there are a lot of other data that gets generated, the data related to what is happening all across, all that is recorded, and that recording is shared. We also see that ISRO is also planning a human space flight mission in low Earth orbit in near future, which will open opportunities for microgravity experiments for various cutting edge scientific investigations. Just I think 2 days back on Saturday, there was a news, and that news was that sprouting in the space, essentially some of the cowpeas, the seeds were flown in the space and these were essentially exposed for further sprouting. It was noticed that the sprouting could take place within a matter of 4 days. Whereas on the earth, traditionally, if we see, when we sow the seeds, cowpeas sprout within 6 to 8 days. So there was an early sprouting observed in the space microgravity conditions. In fact, there has been a lot of research activity that is going on the SPPU campus. There are different groups on the campus which are working on studies related to microgravity. One of the early studies was related to the yield increase in the rice. So essentially rice saplings, they were exposed to microgravity conditions. And this microgravity is definitely not the kind of microgravity experienced by the people or experienced by the objects in the space, but a simulation was performed in laboratory conditions. And these microgravity related activities, they are very much exciting, very enriching. So we can essentially look at, it's not just something which is related to some of the seeds and their sprouting and maybe subsequently their leaves and growth, etc. But these are essentially the kind of initial experiments which would suggest that there will be some kind of farming possible in the space. And farming is essential for naturally generation of food. So when the people they go in the space flights, human space flight mission, they naturally need some food to eat. And it is possible that they can carry the food along with them, but it will be essentially not a live feed. So to get better quality food, there will be need to have some such kind of opportunities, and that's what this particular say news item which was released on Saturday, this has importance. Similarly, in the last week, there was a very interesting news release from the ISRO. This was related to India launches its first space docking mission, SPADX, on 30th of December 2024. Now, what is this space docking mission? Probably we have heard about astronauts flying into space, and then they are going into space in some spaceship, but ultimately there are space stations, and in the space stations they enter through the process called docking process. The spaceships they go and get docked, and then the say entry path is opened and people get transferred to the other side. Similarly, after completing their stay in the space stations, they get back into the vehicles. We know that presently there is a matter of concern for Sunita Williams. Essentially, she was supposed to be on the space station for about a few weeks, couple of weeks, but for some technical reasons, the vehicle which was carrying her that had developed certain technical flaw, and her stay in the space has been delayed. It is increased, where she was supposed to come back to Earth by around July 2nd or 3rd week. She is now seen to be scheduled to be coming back in the month of February. Now, this I just mentioned, so to say that what is docking? Now we can see that docking is something where there are two different spacecrafts. One can see that's what the SPADX mission was. There are two spacecrafts which are flown, and they have their essentially openings. They are independent spacecrafts, but these openings they can join in space. And then there could be some material transfer. There will be some electric power transfer between the spacecrafts. This is basically something like fueling some kind of motion or some kind of aircraft. So some similar kind of exercises they are performed. The space docking schedule is going to happen actually on January 7th, that is tomorrow. This is a precursor of technology for missions like Chandrayaan-4. Chandrayaan-4 is the scheduled mission of ISRO. Chandrayaan-3 we saw that the lander performed a soft landing as well as hopping. Now the hopping was done just to make sure that when there is a manned mission that is say taking place in future, that manned mission should have that particular flexibility of landing at certain place and maybe making a movement. So this Chandrayaan-4 mission is going to be a manned mission, and in that manned mission definitely there will be requirement of docking. So the docking experiment which was done on 30th of December that had that significance. Similarly, it has got significance in the form of collaboration with NASA. The NASA and ISRO synthetic aperture radar. This is a combined venture between ISRO and NASA. This is scheduled to be launched in March 2025. The data captured by NISAR that is NASA ISRO synthetic aperture radar, will be used to measure changes in Earth's surface, including movements as small as centimeters. The 5 resolution images obtained through this will help in managing Earth's atmosphere, water resources, permafrost, soil moisture, earthquake damage, among other things. So we can see that this is a thing which is continuously happening, continuously globally there are efforts. NASA is one of the leading organizations, but ISRO is not far behind. They are collaborating now, and collaboratively they are looking forward for developing something for the humankind. So when we say that there is a space technology, the technology is related to the humans and human, say, kind of clothing, or maybe how they will survive, and space suits and so on. Similarly, for the uh, spaceships, spacecrafts, satellites, and so on. Especially if we look at the satellites, there are different kinds of satellites available. One is called a geostationary satellite. Geostationary satellite essentially is a satellite which is launched from the Earth at a distance of about 36,000 kilometers. It is revolving at the speed such that it performs one orbit in 24 hours, and in that sense it is seen to be stationary on the from the Earth's surface. The medium Earth orbits, these are essentially um, at low altitude, intermediate altitude, like between 2000 to 36,000 kilometers from the Earth, and these perform the rotation around Earth at a, say, smaller time intervals, say 127 minutes to 24 hours. These are the ones which are used primarily for the communication as well as the GPS applications. Then we have the low Earth orbits, which are performing, and these low Earth orbits primarily are essentially used for the imaging purposes, because these are at a shorter distance, and the cameras, they can perform the picturization or the videography of the Earth's movement. And these low Earth orbit satellites, they are useful for that. We can see that the space technology research essentially is related to spacecrafts and satellites. It is related to launch vehicles. It is related to in-space propulsion, related to changing the direction of the spacecrafts or the speeds of the spacecrafts, then performing Earth observations, satellite navigation, providing the data related to navigation, and satellite communication. So we can see that there is a constellation of satellites which performs the location. We are all familiar with the Google Maps and GPS, but probably many of us are unaware that India is doing some effort in this direction also. And in fact, the effort that is done is related to development of Navik, an Indian navigation system. This Indian navigation system is constellation of 7 satellites, and it is performing actual navigation or mapping of around the India as a country, and on the periphery about 150 kilometers extra space, not more than that. So whatever data that is available, that will be useful for the Indians to use within the country, and for others it will not be available, and naturally then therefore it will maintain the privacy. The GPS at present is essentially making it global. It's actually American satellite constellation. So whatever locations we have, wherever we are going, wherever we are traveling, our location status is monitored by some agency which is third party, not within the country. Space technology research is related to development of various equipment, devices, systems, inventions that have been applied for everyday life in human beings to explore and utilize space beyond Earth's atmosphere. It includes technology, infrastructure, and operations used for these purposes, as well as equipment needed to launch and retrieve people and material from space. Space technology research is a multidisciplinary field that includes scientific study of space and use of space technology. It could also be relating to development of space tourism. At present, this appears to be a little remote possibility, but definitely there are private activities like SpaceX. We have seen in recent past that essentially has developed the kind of things where people can go from one place to the other in the space. So this is an emerging sector within the aviation industry that allows people to travel from for space for recreation purpose. Naturally, people with a lot of money, they can make use of this particular facility. The AI and ML is being integrated into space systems to increase speed of decision making, enable autonomous operations, and enhance situational awareness. People are looking for developing reusable launch vehicles. These are being used as a new space technology. Smart propulsion is being tested as a new space technology. We can see that the instruments, development of instruments, development of sensors of different kind like spectrometers for radiation detection, magnetometers on spacecraft used for studying of different planets, stars and other celestial events. In fact, one of the projects which we have been working on as a university faculty, me and some of my colleagues, we were developing some kind of magnetic probe which was expected to be circling around the celestial objects like moon or even earth for that matter, and trying to study the magnetic field from a distance. There were different antennas which were developed, deployable antennas, and these antennas, they were picking up the signals from the extended magnetic field from these objects, and then they were trying to map that particular thing from the perspective of magnetic mapping. This project is actually going on in the university for more than 10 years, and within these 10 years the technology has been completely developed and it is now ready for getting onto the launch. In fact, it was planned that it will be flown on Chandrayaan-2, but somehow it didn't materialize, and now it is being looked at as a future prospect. Within next one of the missions on say PSLV, essentially it will be flown into space and tested, and the payload will be made available. So development of such kind of things are possible. Satellite communication satellites, which enables global communication, television broadcasting, internet services, phone connections. So all such kinds of things, these are presently being used quite extensively. And we realize that, yes, this is one of the major aspects, positive aspects of the space research. Earth observation, essentially satellites carrying cameras and sensors to observe Earth's environment, meteorology, and disaster management. These are the few major applications of the satellite usage. Essentially, one can see that when we talk about camera, probably everybody has a camera in one's possession, in the sense that we have the mobile phones in pocket, and each mobile phone has got a camera. Earlier, there used to be one camera, there used to be two cameras, one front camera, one back camera. Now we see that majority of the mobile phones, they are provided with 3, 4, even 6 cameras. And these essentially are being effectively used for getting better and better resolution and essentially higher capture range. These are the ones which we normally day-to-day experience. But when we talk about satellites, Satellites are at such long distance, few thousands of kilometers, and from such large distance to map objects on the Earth for the satellite Earth observation purpose. Essentially, there is a requirement of very stringent conditions, especially the optics, the lenses, the mirrors, which are included, and these are developed separately. There is a division of ISRO which essentially works on this, developing the cameras systems. The cameras are not the kind of cameras which we use for the mobile. They are different. The sensors could be similar, like maybe the CMOS sensors or maybe the CCD sensors, they could be, but the optics is essentially a very, very stringent kind of development, and such development is being carried out by the ISRO laboratories. We have robotics and AI, which is being used quite extensively. Say, for example, space rovers. These are the autonomous robots, for that matter, for the purpose of carrying out various exploration. Mars rovers flown by NASA, Curiosity, Perseverance, or robotic arms, essentially for purpose of, say, digging out the surfaces of the planets and performing various operations, as well as the operations related to satellite servicing and space station maintenance. Similarly, AI is also quite extensively used in the space missions for the purpose of performing the autonomous operations as well as helping optimizing the mission status. So these are the areas which are very challenging areas. We hear about all these kinds of words, and probably we presume that, oh, we know something about AI and that is good enough. No, that is not good enough. When we talk about space research, it is essentially having a lot of requirements which we need to take into account. Say, for example, through the ISRO Space Technology Cell in SPPU, we fund various research projects, and there are some research projects of using AI, especially related to identifying space debris. Now, these space debris are the ones which is a major problem. On the Earth, we get the problem of pollution or various kinds of things, say municipal solid waste, which is being thrown out, and probably it requires management. And when we say that in space, now there should not be any such problem, but there is a problem, because every country, every mission, essentially when it is flying the objects, parts of those objects, they are released in space. Where do they go? They go and get accumulated somewhere, they remain somewhere, and that causes a lot of pollution. One has to identify that this is an object which is polluting object, which is giving some trouble to the next generation, say satellites or next generation spaceships. So they need to be identified and they need to be cleared so that we get a clear space. And that is a major problem faced by all the agencies across the world, that they find that certain areas, certain regions, certain orbits, they are so crowded that such space debris, they are causing problems for the next missions. And one has to essentially be looking at, say, clearing those space debris, removing them, bringing them back on the Earth, destroying them or reusing them, and so on. So essentially, to identify that such thing is a space debris, one requires use of AI for that purpose. We know that the Indian space program is headed by Prime Minister, Honorable Prime Minister. There is a Space Commission and there is a Department of Space in the ministry. There are several autonomous bodies like PRL, NARL, NESAC, IIST. These are the autonomous bodies which are independently working on various research areas related to space. Then we have the Antrix and NSIL. These are related to different planning of the space mission. In space is such some organization which is basically helping to carry out planning of the new space missions, and these are several laboratories which are essentially established by ISRO, say VSSC, Vikram Sarabhai Space Center, LPSC, SDSC, URSC, UR Rao Space Center, SAC, Satellite Application Center, NRSC, Remote Sensing Center, HSFC related to human space flight research, here IPRC, IISU, INSTRAC, MCF, DECU. Now DECU is something where essentially it is not really related to space, but it is related to use of the space resources, the resources provided by the say satellites for the communication purpose. This is a developmental communication unit. So various places where the traditional communication systems do not work. So maybe one can make use of the communication through the space means through the satellites, and then they can reach the communication for the purpose of education. LEOS is related to electro-optics. IRS is related to Indian Institute of Remote Sensing. So we have these different laboratories, and there is a huge amount of human resource, the resources in the form of various equipment, facilities, and the research activities which are carried out. Now, whenever we talk about the academic fraternity, we have now this academic fraternity. Today, all of you are listening to it. If you wish to plan some kind of research area, you need to identify your own niche, your own liking, what area, which particular domain you would like to work on, and then get somehow aligned to one of these laboratories or many of these laboratories, so that you can essentially develop your appropriate understanding about what are the things which are being done over there, what kind of support those laboratories or those places, those human scientists, they can provide to you, and how you can collaboratively develop activities which are helping ISRO in conducting their future programs. So that's why this slide is put on here. Respond is basically a program which is launched by the ISRO, and this is basically related to sponsored research. The Indian Space Research Organization has evolved a program through which financial support is provided for conducting research and development activities related to space science, space technology, and space applications to academia in India. This program of research sponsored by ISRO is called Respond. This started in 1970s and continuing still. Under Respond, projects are taken up by universities, academic institutions in the areas of relevance to space program. Here we need to understand that the research is a very open kind of activity, but under Respond, any project has to be related to ISRO's activities, space program. So basically we have to modulate our research interests, and we have to see to it that we become useful to the ISRO's future programs. Apart from these, ISRO has also set up space technology cells at premier institutions like Indian Institute of Technologies, Bombay, Kanpur, Kharagpur, and Madras or Chennai, Indian Institute of Science, Bangalore, and a joint research program with Savitribai Phule Pune University. Here we need to understand that this is the only university in the country where such joint research program is situated, is identified. We have signed an MOU 25 years back, 1998, and under this MOU, this activity is continuing. So the academics which are part of the Savitribai Phule Pune University SPPU, they can essentially avail this facility of say applying for research projects under this program. And in fact, more than 200 research programs have been conducted under this JRP over these 25 years. It's a yearly cycle. Every year, applications are invited. They are scrutinized. There is a very stringent scrutiny that is done. After the scrutinization, people are awarded with the research grants, and it's not only awarding of the research grants, but the monitoring also is conducted. Very frequent monitoring is done, and one is expected to deliver certain things to the ISRO collaborators coming from those different ISRO laboratories. Under this program, supported areas of research include space science, which is related to physics of ionosphere, magnetosphere, meteorology, dynamics of atmosphere, geophysics, geology, astronomy, cosmology, astrophysics, planetary and interplanetary space physics, and climatology. Space technology related to rocket and satellite technology, propulsion system design and optimization, aerodynamics, and heat transfer problems related to space vehicles. Again, here we realize that heat transfer, yes, we have basically part of the engineering discipline, but it is not heat transfer in general, it is heat transfer related to the space vehicles. Guidance and control systems for launch vehicles and spacecrafts. Polymer chemistry, propellant technology, which is related to developing the propulsion systems. And in fact, the propellant technology, which is related to launch vehicles, is different, and propellant technology, which is related to thrusters, which are very effectively used in the space for various purposes. Say, for example, in space, if there is a change of orbit required, change of speed required, change of direction required, all those essentially are conducted with the help of thrusters. The soft landing, what we mentioned about Chandrayaan 3, that soft landing was not free fall under gravity. After reaching to a place on the moon in the orbit, the particular lander was not just released and allowed to fall. That was the mission that was done. Actually, Chandrayaan 1 essentially did not carry any kind of say payload similar to the lander, but it had basically what is called as impactor. So from a distance orbit, the impactor was released and it was allowed to fall on the moon surface about 100 kilometers orbit. It was allowed to fall. The soft landing was not done that way. Soft landing was that it was allowed to go down. The speed was continuously reduced, and after reaching about few meters, in fact, thrusters were pushing the thing up and the gravity was pulling, and the landing was effectively very, very smooth. So thrusters are also very important. And to develop the technology for that, to develop the chemistry of it, of the control systems of it, this is very important. We have the ultra lightweight structures where again the polymers, they are important, and though they are ultra lightweight, they have enough strength to withstand the kind of tensions, the kind of pressures which are basically experienced in the space mission. Because when we talk about space missions, the space vehicles, they travel at tremendously high speed, and at that speed, essentially, if the elements of structure they do not withstand, there will be possibility of, say, maybe warping or breaking or things of that kind. Also, there is a very interesting concept in the space that the space objects, whether the space vehicle or even the for that matter the solar panels, they experience a very different kind of situation which we cannot think of on the earth, because we get the sunlight here, solar energy is amply available, and we have the solar panels extended, and we get the sunlight and the energy converted into electricity. But in space, it is not available in that fashion. The reason is that because of the Earth's atmosphere, the sunlight gets scattered and it is available uniformly everywhere. But in the space, the sunlight is not available uniformly everywhere because there is no atmosphere, there is no dust, there is no scattering, and therefore the light is available only in the sun. So whenever the space vehicle is passing through the sunbeam, maybe it is quite possible that part of its say surface is getting the direct light and part of it is not getting any light. Now under this situation, the temperature is so low, maybe minus 40 or even less on one side where there is no light, and where there is a light, there is temperature rise. Maybe temperature could be maybe 50 degrees, 100 degrees, 200 degrees, and such differential temperatures, they essentially cause bending of various space objects. So the objects related to the space uh, vehicles or the objects related to the solar panels, they need to withstand such kind of differential temperatures. So we need to really look at this kind of situation also, which is not normally experienced by us. There are different kinds of space communication systems, space electronic systems. Now, space electronics is facing a bigger challenge in the sense that the electronics is not just exposed to temperatures, temperature differentials. We say that okay, space grade electronics has to withstand temperatures from minus so many degrees centigrade to plus so many degrees centigrade. That's fine, but in space there is one more element that comes in, and that element is the cosmic showers. Various kinds of particle matters, ionic particles with high speed, they impinge on the electronic systems and they cause a lot of damage in the electronics. The radiation, cosmic radiations, they are the major causes of failure of electronic systems in space. So one has to be aware that the things have to be space hardened. The space communication systems, we talk about, say, navigating on the Earth's surface through the GPS, but how there will be navigation possible in space? Say on moon surface, say for example, there is no GPS available, no signal available. Now, when we talk about telemetry and tracking system, there is a command to be sent, there is sensing to be received, means the position or whatever parameters they have to be received back. So this requires a good communication system. But such kind of communication systems, they require antennas of different kind, they require transmitters. Now when we say transmitter, to transmit signal from such large distances, maybe a few thousand or few lakh kilometers distance to the Earth's surface, this is going to be a challenge because for such long distance coverage, the requirement of power will be very high, and power is something which is not readily available there. You have very minimal power available, and within that minimal power, how you can establish effective communication without losing communication, how you can essentially have the controls working appropriately. So all such kinds of things, these are the challenges, and these challenging fields, challenging areas, they need to be paid attention to when we as academicians, when we say as scientists or engineers, we need to really pay attention to all these and try to get the solutions to that. Space applications, variety of space applications are there. Maybe the applications related to finding the measurement of shape or gravity, space orientation of the Earth's surface, that is called geodesy, or image processing related to the satellite imagery, and then getting the satellite imagery appropriately understood and manipulated, including the weather forecasting or education, ecology, and all such kinds of things. These are open areas of research, and these areas of research, they are quite exciting, quite interesting. Only thing is we have to have the patience, we have to appropriately decode what is there and find our niche and focus on it and get the things going further. So we can see the applications of space technology. They are in the agriculture, forestry, and so on, oceanography. In fact, one of the major missions of ISRO has been developing OceanSat, and this OceanSat is helping the marine life, means the uh, marine vehicles uh, effectively for navigation purpose, as well as identifying the areas where one can have proper catch of fish and so on. So a lot of research that is going on in that domain. It can be used for environment monitoring and maybe making corrections, agriculture, forestry, communication, various kinds of urban planning related things which are related to, say, maybe having some kind of remote sensing maps for different kinds of services, even disaster management related to disaster situations where the flooding or earthquakes or maybe the landslides, they can be effectively used. Glaciology, satellite imaging for different purposes in the energy sector to identify and locate where the particular things have to be put in, mining the minerals where they are deposited and how they can be effectively excavated. In addition to that, we need to understand that space technology or Indian space missions, they are not just looking at developing things related to the space. They are looking for spin-off solutions also. Say, for example, space technology has evolved beyond curious exploration to solving real-life problems on Earth. It plays an increasingly pivotal role in efficient functioning of modern societies and their economic development. Space holds the power to unlock highly impactful solutions at scale and directly impact the lives of billions of humans. ISRO has carried out critical value addition activities in-house for Chandrayaan mission. So various things which have flown on the Chandrayaan mission, they have been indigenously developed through the Indian industry, and accordingly the Indian industry capacity has improved. Similarly, for the Mars mission also, Indian Regional Navigation System, NAVIC, I mentioned earlier, with the private industry's contribution by subcontracting. So their capabilities have also equally been improved, because anyway, ISRO in-house cannot develop all those. This, I think we need to understand, and we need to keep in mind that whatever activities which are there, these have to be done in collaboration with ecosystem around. Space technology offers means to address global challenges and encompassing satellites, space stations, ground stations, monitoring and tracking centers, downstream analytics, and AI, software, etc. The satellites offer a cost-effective way to build capacity of for Earth observation. Satellite-based Earth observation data is essential, etc. So this is basically Indian Regional Navigation System, IRSS. NAVIC, I mentioned about that this is covering the entire India and 150 kilometers beyond that. Now, I talked about ISRO so much because I have been associated with the ISRO last so many years. I recall my first research projects which I submitted through the joint research program of ISRO and SPQ. That time it was University of Pune, 1998. That was my first research project submitted to ISRO. Subsequently, I was associated with the Joint Research Program STC as a researcher, as say, member of the program execution committee. Subsequently, after my retirement, I became the director, and now I am handling for last almost 5 years. I'm handling the responsibility of director of this center. So I talked in detail about the ISRO's programs or space programs and the research funding opportunity available. As I said that through the JRP, we can have the opportunity for the uh, institutions affiliated to SBPU. You can approach us. Every year we release the advertisement, and in response to the advertisement, the proposals are invited. They are scrutinized. They are further scrutinized by the ISRO's laboratories. A collaborator from the laboratory is very much needed. So such collaborators are identified, and in joint collaboration from the ISRO laboratory and the academic institution, the research projects are carried out. The funding is made available for that. Now, on similar lines, we find that there is another sector, which is the sector related to defense. And for conducting any kind of activities related to defense, especially development purpose, there is a organization called DRDO, Defense Research and Development Organization. Now, Defense Research and Development Organization also is equally strong in the country. In fact, through the Atmanirbhar Bharat Yojana, there are various Make in India activities which are being effectively utilized for developing the defense related technology development in the country. The products are being developed, and the DRDO has number of laboratories, 41 laboratories across the country, out of which in fact almost more than 10 laboratories are situated in and around Pune. And these different laboratories, they are contributing significantly in various kinds of developments which are related to activities like aeronautics, armaments, electronics, combat vehicles, engineering systems, instrumentation, development of missiles, advanced computing and simulation applications, special material development, naval systems, life sciences, training information systems, and agriculture. Probably here some will wonder why life sciences are included here, but it is important to note that defense is something which is related to providing the defense services across all the terrains. And in fact, especially in the border areas, we find that there are extremities in the weather conditions. Siachen, for example, has got very extreme low temperature and difficult situations, whereas maybe the deserts of Rajasthan, they are high temperature and different kinds of uh, challenges are there. So in these different situations, the kind of people who are essentially uh, contributing into the India's defense, they have to essentially withstand all those challenging situations, and that's where the life sciences related to the health of the health of the military personnel, related to their food, their situations over there, maybe any kind of treatment of ailments. So all such kinds of things, they come under life sciences. Several major projects for the development of missiles, armaments, light combat aircrafts, radars, electronic warfare systems are on hand, and significant achievements have been made. Say radar systems or missiles. In fact, Pune has got ARDE, where there are lots of missiles being developed, ballistic missiles, cruise missiles, anti-ballistic missiles, surface to air missiles, anti-tank guided missiles, and so on. Electronic warfare systems, where there are various kinds of systems which are getting engaged, and communication aspects related to it. Maybe some of them, they are radio communications, some of them are optical communications, and various kinds of encryption, decryption techniques they are effectively utilized. There are OFDM which are being developed in the recent times, and they are utilized for this purpose. Various kinds of say warheads which are fired, how they have to be properly trapped and they have to be destroyed. This also is a kind of mechanism method which is developed by the electronic warfare system. So we can see that there are lots of things which are happening around in the electronic warfare systems. Different armaments, their say thrusting power, various kinds of indigenous assault rifle development by DRDO, uh, the structure of the rifle, the kind of artillery which is used, firing of the missiles. So DRDO research boards, they are the ones which support the research and development in this fund. The funding opportunities, they are available. You can apply to the DRDO research boards. The advertisements are released every year, and academics can approach them, submit the proposals. The proposals will be evaluated, and appropriate proposals will be funded by the research boards. Say there is a research board on aeronautic research and development. There is another research board on armament research board, life sciences research board, which is related to life support system and biomedical devices, soldier health and drug deployment, physiology of extreme environment and behavioral science, biotechnology and bioremediation, food, agriculture and bioprospecting. There is a naval research board, and depending on our own interest, our own capabilities, we can visualize certain proposals, and maybe with the help of scientists in these different laboratories, we can fine tune them and present them in front of these research boards and get sumptuous funding. Say we have been working in the university with development of various technologies related to DRDO, and we have received generous funding for different research proposals which we have submitted. So you can also carry out such kind of things and formulate such proposals. The important thing is that these proposals, they need to be directly usable by the defense, and other thing is that secrecy or the classified information is very important, because you need not make it open, make it available to the others, even for making a publication. So when you carry out research, probably you feel that the research should be published, the research outcome should be published, but even for publication you need to get permission from the research boards. They give, only thing is they evaluate in the first place whether releasing this information is going to cause any threat to the defense, and if they find that there is no threat, it's only a scientific information that is being released, then they give permissions also. But you have to be careful giving that particular thing. To foster innovation and technology development, there are these recent kind of initiatives by the Government of India, Department of Defense. There is a IDEX competition or IDEX challenges. These are also announced every year, and through the IDEX, this is a collaborative platform for stakeholders to co-create and develop innovative defense technologies. The IDEX run challenges for Indian startups. These are not purely for academics, but academics are not excluded. Some of our colleagues have presented in the IDEX. They received good inputs, some funding also. These IDEX runs, they look at Indian startups, MSMEs, as well as individual innovators. Under this category, we can say that we have the academics opportunity. Thematic open challenge and advanced defense innovation challenges, acting development for innovative, this Aditi challenge. So these different challenges, they are every year released. In fact, every year there is a list of such challenges, and you can identify which challenge you can fulfill, and you can apply, and they give you good sort of, it is not a funding grant in aid, but it is actually a purchase order. IDEX aims at creating an ecosystem to foster innovation and technology development in defense. They provide grant funding and other support to carry out R&D, which has good potential for future adaptation for Indian defense and aerospace needs. I said earlier that grant is not there, but this grant, they say that this grant is related to getting the product ready. It is not just for open research. So it's not a open research kind of grant. It is basically grant related to developing a product which has got a good potential for future adaptation. So we have basically number of different opportunities. As academicians, we need to make a list of things which we can develop ourselves. We can get engaged into the research activities in the defense as well as space technology. There are different opportunities. One is developing reliable propulsion system, and this is not just for the space but even for the missiles of different kinds. Designing spacecrafts and systems that can withstand the extreme temperatures, radiation and vacuum of space, as well as forces of launch and re-entry into the Earth's atmosphere. This is another big challenge, because when we say that things are launched from one place on the Earth, as long as it is within the Earth's atmosphere, probably it is facing some challenge, but not a big challenge. But when we say that it is escaping out of the Earth's atmosphere, there are various kinds of forces which are acting, and that is where essentially there will be a bigger challenge. There are things at the time of re-entry also. Say when you enter into the Earth's atmosphere, the friction that is created, it creates huge amount of heat, and probably the spacecraft can catch fire. Developing ways to sustain life and support human missions in space, including systems for life support, thermal control and waste management. Creating technologies for space satellite communication and navigation. Developing robots, automated systems that can perform tasks and conduct research. This includes, say, various kinds of support systems for the soldiers also. Physics, chemistry, biological sciences, mathematics, computer modeling and simulation. This could be major, or rather some of the domains where we can contribute, but we need to adapt them to the situations related to the space and defense. One can have aspects related to aerospace engineering, mechanical engineering, electronics and communication engineering, computer science engineering, material science, instrumentation engineering, etc. So there is undoubted global front runner as India is, and this is showcasing its capabilities in the form of different missiles as well as in the form of launch vehicles which have been indigenously developed. Let us contribute our little bit into it by way of our own research activities which are coordinated, well coordinated and ready to deliver things for the organizations from which we receive funding. Thank you. If you have any queries, questions, please feel free to ask.
Yes, participants, the forum is open for question answering. You can unmute yourself and one by one you can ask the questions. Yes, Alfia ma'am, Professor Alfia.
Good evening, everyone. I'm Alfia. Sir, actually, I have just started with my PhD research work, and I was planning to work on aerial forms of data. So can you suggest me any topics that I can look into? if I have to consider any aerial data sets or anything in that way?
Yeah, in fact, you need to define like what kind of nature of data that you'll get, because in the space and defense there is huge amount of data available, and
Okay.
much of the data is of course classified, so we need to really be careful.
Sir, a
Generic
top.
data which are available in the open domain.
Yeah.
Yes, please.
So sorry to interrupt you, sir. Actually, sir, I was looking for oceanic data. So is there any publicly available data sets for oceanic information, image sets or anything?
Yes. They are available on the ISRO site. Yes. Through the
Okay, sir.
OceanSat, what has been collected, the data sets are available on the ISRO sites.
Okay, fine. Thank you so much, sir.
Okay.
Yeah, the next one we have Gopinath Gudipatti, sir.
Hello, can you hear me?
Yeah, go ahead, sir.
Yeah, I'm Gopinath from ONGC. I just want to know that whether this NAVIC system can be, it says that it is around India and 120 kilometers is possible to navigate, but is it possible to navigate globally? It is expanded.
No. Because of the geometry limitations, it cannot go beyond. Earth is spherical, and because of the geometry limitations and the constellation of satellites which have been formed, it is limited to only India and 150 kilometers around. Extension.
No. My question is related to in the warfare, we go to some other countries during that time. We have to use our own NAVIC system. In that case, how it is possible to? You have to hire from somebody. In that respect, what was the for our ONGC, we go globally for exploration, and we extensively use our navigation system, which is sometimes we need accuracy of about 1-2 meters. So that is my with regards to that, my query was.
So with that regard, presently the NAVIC system is having the 7 satellites, and the constellation of 7 satellites is limited to India only. Beyond that, we have to rely on the different kinds of pacts and different kinds of arrangements, commercial arrangements, which as a country we have, and we have to hire naturally the data. Presently, we are not using NAVIC at present. We are using GPS, which is a US navigation system based on the US constellation of satellites.
Yeah, actually that they don't give the very accurate number of accuracy required. That's why I think it is good to have our own navigation globally, so that we can expand our business also, business purpose also. That is why.
Yes, true in some sense, but see, it has its own limitations, because if you want to launch vehicles all and the satellites all across, then definitely that will be requiring huge amount of investments and lot of permissions from different international organizations. So presently that is not on the radar.
Okay, thank you.
Yes, I think Director, sir, you want to ask something?
No, I just want to participate in the discussion, which our person from ONGC who has asked this. So my view is that, I mean, having this NAVIC system in itself is a big achievement, because till now we didn't have our own navigation satellites and GPS system. So this itself is a big achievement. And from the defense point of view, what is important is to have your own system in your own area of influence, which is your own country and little bit around that.
Yes.
So that is what is important.
True.
Because tomorrow in a situation of conflict or war, if you are dependent on foreign GPS, even if it is US, they can influence your navigation.
They can influence and mislead
you. So what is more important right now is controlling your area of influence. And we know the India as such, as a country, peace loving country, our aim is not to go across continents and carry out any operations. And if we go there, we go as a peacekeeping force. So where we can depend on the United Nations provided GPS systems. So that is the whole idea of having, and as very rightly brought out by Dr. Shaligram, if you have to go beyond our area of influence, it will incur huge amount of investments, and as you know, international treaties and all those things are involved in that. So I think what we have done and what ISRO has achieved is something itself an exemplary thing. Thank you.
Thank you.
Thank you, sir. Yeah, any other questions for the participants? I think they are done. Okay, so thank you very much, sir. I would like to express my sincere gratitude for the enriching talk you delivered on the topic overview of defense and space technologies. Your session started with the basics of microgravity and its potential application in space farming. To the current advancement in space docking missions and Chandrayaan was incredibly insightful. So you emphasize on various funding opportunities that are there, like Respond, DRDO labs, IDEX for defense particularly. They were motivating. So I hope participants enjoy this session and they will take a benefit of this. Yeah, thank you. Thank you so much for joining with us.
Thank you. Thanks for the opportunity.
Yes, welcome. So you can stop sharing. Shadiram sir, can you stop sharing?
Yeah, I'll do that.
Yeah. Thank you. Thank you, sir.
Thank you.
Yeah, so we are going to start the next session. And the next session is on information warfare. And the speaker of this session is Brigadier Abhay Bhatt. We have already introduced Brigadier Abhay Bhatt. I'll briefly introduce him once again to set the tone, and then he can take over. Brigadier Abhay Bhatt is an alumnus of National Defense Academy, was commissioned into the Corps of Signals in 1982. He has done his BTech in Electronics and Telecommunication from Military College of Telecommunication Engineering, Mahu. Brigadier Bhatt has graduated from the prestigious Defense Service Staff College, Wellington, where Army officers are trained in the nuances of staff function of various operations. Due to his professional caliber, he was sponsored by the Army to attain MTech in Computer Science and Engineering from IIT Kanpur. The officer has also acquired a master's degree in personal management from Pune University. He has served in counter-insurgency areas of Assam and J&K. Brigadier Bhatt commanded an armored division signal regiment during Operation Parakram and has served on the staff of MS Branch. He was also involved in implementing IT projects for developing information technology infrastructure in remote areas of Northeast. For this, Brigadier Bhatt has been awarded the Chief of Army's Commendation Card in 2011 for outstanding work in the field of signal intelligence in support of operations in J&K. After retirement, he joined Army Institute of Technology, and currently he is the director of Army Institute of Technology. Today, he is going to talk on information warfare, which is a very keen topic of this FDP. Over to you, sir.
Thank you, Dr. Rane. Can you hear me?
Yeah, I can hear you, sir.
Okay. So Thank you for the lovely introduction. First of all, because we have a large attendance here today at 7:30, that itself motivates me a lot. I think 78 I can see are attending already at 7:30 in the evening and expected to go on till about 9 o'clock. I'll try, of course, try to finish it as early as possible. So I am certainly not an expert or not a professor who has a big research background in this field. However, my practical experience in while being in the army and last few years have been following the developments in the information warfare uh, in the scientific and defense arena. So I will try to share some of these experiences, some of my ideas, and I would request that through the question answers and through your exchange of ideas, we can develop this topic further. So with this declaration, let me start sharing my uh, presentation. And I am again mentioning that there is no particular structure that I am following, but my observations and my experience is what is being shared. Share, okay. Can you see this presentation?
Yes, sir. Yes, sir.
I'll just do.
Make it presentation mode.
There's something wrong.
No,
Yeah.
right side, topmost right. No, below that, the right corner. Yes, last icon. Yes.
This one. Something wrong here. What did I do?
Yeah. So can you see the last icon where you click now? Last icon. Just click on last one. Now.
No, not this one. Okay, let me see.
Share it again.
I'll again share it.
Yes.
Stop sharing. Share. Screen. There it is. Okay, now I can.
Yes.
It will be covered by this window. ये शेयर करते समय कुछ प्रॉब्लम आ रहा है एक सा विंडो था ये विंडो था ऐसे वाला हाँ ठीक है आई कैन नाउ शेयर इट
Yes, that's correct.
Can you see it now? Okay.
Yeah.
So to start with my presentation, this is information warfare. So I have underlined this fact that it is a warfare of 21st century. Why is it so? So till now, warfare were of different kinds. There was an era when warfare were between infantries with swords. Then came the era when the warfare, they brought in firearms, then cavalry, then came the various machines, artillery, then came the tanks and the aeroplanes and other, kinetic, I will call it kinetic agents, which participated in the warfare. In recent times, space, which was again topic today, has become a very important agent of warfare. And today, in the 21st century, we all know that this is considered to be an information age or information era. So warfare too has moved into the information warfare domain. I will explain you further about this as we go forward in our presentation. So this is again a very old quote from Napoleon Bonaparte. So it is finally in any between when there are two nations or even two agencies which are fighting, two organizations which are fighting, finally it is always the mind, how you apply your knowledge, how you apply your mind which leads to victory. I have just picked this up very recently. Now, this is not about just about warfare. It is about the risk. The World Economic Forum, which surveyed some 1,490 leaders about the top global risks in 2020. This survey was conducted end of the year 2024, which we just changed. And what are the potential threats on mankind? Of course, extreme weather was the topmost. Can you imagine the second one was AI generated misinformation and disinformation, which now today forms a huge part of your information operations or information warfare. And in top 5, we had cyber attacks also. Nearly 39% responded with cyber attacks as one of the potential threats. Again, so in top 5, we had two such elements, that is AI generated information or misinformation and cyber attacks, constituting the top global risk in 2024. And going forward, this percentage is surely going to be much higher. Now, when you talk about national security is the security of a nation state, including its citizens, economy, institutions, etc. What does it encompass? Of course, borders, frontiers, national assets, security from insurgency, terrorism, crime, energy security, environmental security. A very important aspect today is of information and data, as well as the cyber domain. And of course, economic and other security also become part of your national security. So that is very, very, very clear. This is, of course, a definition of national security very well understood globally. Information, data, and cyber form an important part of your national security. Today, of course, I'll be covering domains of warfare, information warfare, basics, cyber operations, forms of attack, India, neighbors, and role of our common citizens in the whole gamut of information warfare. Because what is domains of warfare? So when we say domains of warfare, these are areas in which your operations during war are carried out. So land, sea, and air, three important: Thal Sena, Vayu Sena, Jal Sena. These were, of course, always very, very important. Then space has become another domain of warfare, and cyberspace of information space. In last 10 years, world over, the military strategists are now considering this as an independent domain of warfare. Why is it so? We can see this further. So land, sea, air is well known. Army, Navy, Air Force, then you have space agencies, and cyberspace. So these have become now as important as land, sea, and air. Now there is a concept of hybrid warfare in last many years, since I think last 10 years or so, people are using this term very, very frequently. But today warfare is not conventional, neither is it kinetic. Kinetic means using force or energy, which is either in terms of bullets or in terms of movement. But it is hybrid. And hybrid would mean it employs political, it employs various conventional in itself, irregular, cyber, and there are many influencing agencies, like it's mentioned here: fake news, diplomacy, electrical intervention, and all this we have seen in the last 10 years happening at a very large scale, at international scale. And whatever conflicts I mentioned in my opening address today, we see around us, you will find all these are hybrid conflicts. For that matter, many of them involve non-state actors. That means those actors or those organizations which are not affiliated to a particular government or particular state government. So here you have, so it's a mix of irregular and conventional warfare, which is called hybrid warfare. So today, all the conflicts you see, without exception, are hybrid conflicts, and in which cyber and information warfare has become very, very important. I've just given some recent examples. So, of course, the very old example of Pakistan's support to insurgency in J&K, and of course other insurgencies. Even in the earlier days, it was Punjab also. Iran's proxies. We all know Iran is not fighting a direct war with Israel or with other US allies. but it has its own proxy, the Hezbollah organization, the Houthis who are operating from Yemen, and Hamas. We all know what has happened in recent times. Hybrid warfare, explosion of pagers in Lebanon against Hezbollah carried out by suspected Israeli agents, non-state actors. And this was not a direct war also. Russia's annexation of Crimea in 2014, again not through regular force or regular operations, but again through an indirect manner. And of course, what is happening thereafter? Hamas attack on Israel in October 23 and later narrative building. I specifically added this later narrative building as an important aspect that you must understand. So there was a brutal attack on Israeli civilians by Hamas in October 23. You all remember that. What had happened after that? This war is going on still. And while Israel was the victim of these operations carried out by an organization which is not a state organization, it's a terrorist organization or insurgent organization. But the way the narrative has been built by various organizations and people supporting Hamas, you all know that they are getting this, sympathy or empathy from a large population in the world. Come on. Of course, what Israel did and what it did later is also again a hybrid warfare. Again, they also tried their own narrative building. Current Taliban versus Pakistan conflict. You all know that very recently, Taliban has attacked many posts in Pakistan along the Khyber Pakhtunkhwa. And again, they are supported by another organization in Balochistan called BLA. So this is happening. As we speak, these conflicts are happening. And Israel and Iran conflict, where there were a number of things that have happened again through Hezbollah. There was a rain of missile fire on Israel, which they successfully defended. Israel also carried out some operations in Iran clandestinely. It is suspected. Nothing can be pointed out very clearly. Hybrid warfare. Again, this is again old news that Chinese hackers about 4-5 years back, they pillaged Taiwan's semiconductor industry. Taiwan has got the top semiconductor industry in the world, and Chinese wanted to take control of that. So the hackers managed to carry out this kind of a operation. Even our own clash at Galwan, was it a regular army operation? No, hardly any bullets were fired. The Chinese came in, we responded, they carried out some operations, or the CO and some other soldiers were killed. We carried out some operations. It is claimed that maybe about 40-50 of Chinese were killed. So again, hybrid operations. So an important aspect or important part of all these operations is information warfare. What is it? Any action to deny, exploit, corrupt, or destroy enemy's information and its function, and while doing that, protecting our own against enemy's action and exploiting our own military information functions is called information warfare. Now, this is a definition, but I will now go beyond. It is not only military information function; it is entire country's information data infrastructure, which we can now can be included in the information warfare, which has got many ways that people define. This definition has over a period of time expanded. This definition has now become much more larger, and there is a complete blurring between the civilian function and the military function in this warfare. Also, there is a complete bearing because this is a continuum. There is no time in which you are not on carrying out information warfare. There is no need of declaration of war, even declaration of hostilities also. This is continuing throughout 24/7, 365 days. This is again an aspect of information warfare. When you try to look at components of information warfare, people define differently. This is one definition which I very recently took from a US research paper. So information, it will have various domains. Within the information domain, there are other domains. So there is a physical domain, there is the information domain, there is cognitive domain. Okay, we'll leave aside the other annotations. Let us go forward to understand what is the physical domain. So when within an information domain you attack the devices, networks, wired or wireless sensors, they become physical domain. So if you introduce something which will cause physical damage, for example, the Stuxnet virus in Natanz in Iran many years back, I think 14 years back, it caused complete breakdown of their nuclear production facilities. This again suspected that the virus was introduced by probably Mossad or probably some CIA agency which stalled the Iran's nuclear program. Again, the same example, attack on Hezbollah pagers. This may not have be carried out in the conventional fashion, but this attack was carried out by a very clandestine operation. And the pages exploded, simultaneously killing many of the Hezbollah operatives. Ukraine-Russia war, the huge amount of damage is being done by using information warfare. Physical damage is being done. So smart bombs are being made ineffective by GPS, jamming of drones, which because of it the drones are killed. It is reported Ukraine is losing thousands of drones a month. Probably similar things happening to Russia, because these informations are coming through various agencies. Some Western agencies are giving their reports, some Russian agencies are giving their reports. There are kinetic weapons also available today, anti-radiation missiles. So you can jam the complete radiation and make these radiations these devices totally ineffective or destroy them. So there are so many kinetic or physical effects which can be carried out by using information warfare. Even the famous EMP, what they call electromagnetic pulse weapons, they are causing huge physical damage, but it's in the realm of information warfare. Information domain, when you attack the data, knowledge, software, for example, when you carry out information theft using trojans, stealing of nuclear plant secrets, then if you recollect, the CrowdStrike's sensors some security software in July 1924. CrowdStrike is again a cyber security firm, and it is providing the security coverage to Microsoft Windows. But what had happened? There was a bug that was claimed. It was again declared that this was an inadvertent bug. But imagine if that same bug would have been introduced by a hacker, then it would have become information warfare. We don't really know. Claimed by that company, it is inadvertent software fault by some low-level programmer, because of which this outage had caused. Okay, so that is what an information domain means. That means you carry out an operation in which your information domain soft targets are affected, causing an operational failure. And there is a cognitive domain where your mind, your cognition, that is human mind or group mentalities are affected. Sense making, and it is also called sense making and meaning making. That means you carry out a narrative, set a narrative. So again, I have the same example of narratives post Hamas attacks. There are narratives which are carried out world over. They will show you some video which may be not accurate. They will show you some pics. They will carry out deep fakes and build a narrative amongst the target population, which will try to support, try to not support, try to create a situation. So again, there is an example of 12th September 2021. They circulated 131-page dossier titled Indian Human Rights Violation in Indian Illegally Occupied IJK. And it made preposterous claim that India is managing ISIS training camps. They're using chemical weapons in Kashmir Valley. And the intent of the dossier release is promoted by Pakistan government only to sustain an anti-India narrative. Similarly, India also carried out its counter since abrogation, and we have been constantly focusing on material incentives, development, industrialization, how the tourism industry in J&K is growing. And this, we are again trying to provide an ammunition for the cognitive domain in the positive manner. So this war of narratives, war of perception is an information warfare carried out in cognitive domain. Your cognition, your mind, your logic, your perception is affected. Very recently, if you have been following the international events, what had happened in Bangladesh when Sheikh Hasina's government was overthrown? A very it started with some reservations or some facilities provided to the 1971 war heroes and their families. And there was a opposition against that. There was a judgment in the court based on which the government was providing these facilities. And when the whole narrative started building up and protest started building, the government even withdrew that, even against the court orders. But the damage was already done. A narrative was set. Narrative was set against Sheikh Hasina and her party, Awami League. And the whole country started boiling. And she had to literally run away from there just in the nick of time. And you saw the government has changed, and Bangladesh is going through a very different crisis now. So what can happen by in cognitive domain? It can affect the entire nation. Arab Springs, about 10 years back, if you recollect, there were 3, 4, 5 countries where this, riots and these uprisings affected the change in the regimes. What happened in Syria recently? Again, the build-up was done in the cognitive domain, which resulted in a war-like situation or conflicts in that region. Indian Army view of information warfare. Sorry, this earlier shouldn't have been there. So we have in our what do you say, Indian Army doctrine, we have three this thing of information warfare subparts. One is a psychological warfare. We talked about it, something like a cognitive. Cyber war, which is again affecting all the entire cyber domain, or whether information, software, data, or even such whatever, when we are utilizing the cyber tools to carry out. And electronic warfare is more or less like in the physical domain. So these are sub parts of all these information warfare, various components. So your cyber domain, computer network attack, computer network defense, and network exploitation. We will talk about it as we go forward. In psychological, public information, perception management, I talked about it. Public diplomacy, again, how you carry out diplomacy across the international arena is also very important, because that's what will create a psychological, upper hand towards you. And in electronic warfare, you have electronic support measures, electronic countermeasures, electronic countermeasures. So PsyOps, I give you some examples. I'm moving forward fast so that this is something which it is again a huge area of influence in psychological operations. And today, these things are again, evolving. The psychological operations, perception management, narrative building, deep fakes. This is a continuously evolving process. And as I will claim that many times these are operations which are now not in the hands of the government itself. There are so many agencies which can control these. Cyber warfare, again, network defense, operations, intelligence collection, etc. And there are operations. CNA is operation disrupt, deny, degrade, or destroy information resident in computers and networks, or the computers and networks themselves. Okay, so defensive is very important for us, because through the defensive operation only we can avoid CNE or CNA operations of the enemy. Again, this is part of our CND, that is network defense. So when we carry out a network defense, we have to carry out defense of entire cyber domain. So it is network, platform, application, file, data, all these things we require various ways in which we. So for an organization, let us take an organization has to carry out a network defense. We will require a large layered defense mechanism as shown here, starting from firewalls at the outer level, demilitarized DMZs, then various ID management, content filters, traffic filters, etc. Then the antivirus, patching system, security specifications, secure coding. So your software code itself has to be tested for whether it is secure or not, whether it has got bugs, whether it has got vulnerabilities, and there is expertise available in this field also. And finally, your file data, enterprise right management, how well protected they are, and what kind of risk is involved in the main manner in which they are managed. What is the importance of cyber warfare? Why is cyber warfare that important? So cyber attacks are so inexpensive and easy to mount. Even young 16, 17 years old students or so-called nerds can carry out this attack. You could fund an entire cyber warfare campaign for the cost of replacing a tank thread. Tank thread is essentially the chain that propels a tank. Why don't you want to create specific any organization, and not necessarily governments or state governments, any organization, be it terrorist organization or a small organization, can indulge in developing this expertise where you can cause extensive damage in either in physical manner or in information domain or in cognitive domain. So you see how many internet users? 68% of the world. Top three countries: China, India, and USA. Number one is China as far as internet use is concerned. Internet, including the internet on 5G, 6G, and all that. And India is number two today, and may become number one at some stage. There are a huge number of IoT users. We don't even know. This 40 billions may be an understatement. So IoT, as IoT grows, there will be the things which will be using internet. So 5.5 billion world population. The internet users is limited by the world population, but IoT is not limited by any population because they are the things, they are the devices, they are going to automatically use the internet. So now, as we already brought out, the cost could lead to asymmetry. Asymmetry means even a small David can challenge a Goliath of a state or a government or a country. So even small bunch of very, very motivated, very, very technically expert and well-trained people can cause extensive damage for a much larger organization or much larger country. As again, offensive cost is far lower than the for defense. This is very strange. Normally in the army parlance, they say that to launch a conventional offensive will cost you 3 to 4 times in terms of resources than to carry out defense of this for the same objective. For example, if I have to hold a particular feature, a hill feature or a post, the number of troops I need to deploy, the amount of firepower that is required is only 1/3 or less than 1/3 actually. 1/3 is again depends again on the terrain. If the terrain is your friend, for example, a mountain terrain, then you will require only 1/9 of the force that is required to capture that post. So that here it is other way around. So defense costs much more than your offense, than your attack. Attack costs very little. Defense costs huge. As you said, we talked about layered defense. So just the cost of a firewall, we all know. All of you have got firewalls in our organization. An hardware firewall for a small organization like us can cost anything between 15 lakhs to 20 lakhs. And then other paraphernalia. Many times you don't know from where this has been initiated, where the agents are coming from. They could be bots. So there is an intraceability and deniability also. They can deny. We have not studied it. As the Israelis have denied this pages got exploded. We don't know how. Stuxnet virus. Nobody has claimed the ownership of that. There could be cyber militia, cyber criminals, cyber hackers. All are part and parcel of this whole warfare. And it's always a campaign time. 24/7, 365 days, somebody is going to attack somebody. The attacks are taking place something like 50,000 in a second in a country. That is the kind of scale that attacks take place. It's always a campaign time. Again, historical perspective, I will go one by one. So in the recent times, the well-documented cyber attack carried out as in support of conventional warfare are like Estonia, again by Russia in 2007, Georgia in 2008, the Stuxnet virus I talked about, the impact of Russian intervention in US elections, ransomware, WannaCry, and there are many such examples. So Stuxnet, I'll just give you one example because I mentioned 3 times, so I thought you will all be curious. So what is this all about? This was an attack on nuclear reactors in Natanz in 2010. It's also called Operation Olympic Games, code name given to it. This worm was developed in under development since 2005. They were targeting the supervisor control and data acquisition system called SCADA, which are used in the nuclear reactors. So they used an infected USB drive. Very, very ingenious way of infecting. Everybody knows that a nuclear installation of any country would be highly protected. They will have all the procedures, SOPs and all for using. And SCADA is generally not using the standard operating systems also. They have their own, because of it is using its own operating system. But what they did, they just left, somebody infiltrated, some guard or somebody just left 2 or 3 USB drives in on some tables or some places, and then those people who are working there were trying to find out whose USB drive is it, and by mistake insert it in their own system. That was enough just to find out what is whom to whom this drive belongs, and that infected the whole all the their system and their so-called turbines. They started running at a much higher speed, which caused damage, heated up, and caused extensive damage. Centrifuges. Okay. Now, US presidential campaign, it is claimed that it was a systematic hacking of their organization, the individual. Then this information was released in a very strategic time. It is also said that now these are all suspicions. There is no clear evidence. As I said, traceability is very difficult. That it's state-owned media organizations, and they were used to spread pro-Russian narratives and propaganda. Social media sites like Facebook were used to set up divisive fake political pages and Twitter trolls. We don't know what had happened that time, but what happened ultimately was Hillary Clinton was painted in a very negative light in this client campaign, and there were so many accusations against her, which the fence sitters then decided to vote against her, which may have caused her defeat at that time. So as brought out earlier, even the electoral outcomes can be affected by information warfare. Ransom warfare, we all know today is a very common thing, and ransomware is used to affect many countries, but this is one of the biggest attacks was in 2017 or 23. 230,000 computers were infected in 150 countries, which included India also. Of course, I will just move this forward. We all know, because now coming to capabilities of various nations, US has well documented capabilities in cyber warfare. It's led by a 4-star general. But of course, in all cases, as respect to all countries, many of the capabilities will be hidden, unknown. What is on the front is only what we know. It is said, though US claims to be one of the biggest targets, it's also largest generator of malware. It's got a cyber mission force of over 6,200 military civilian personnel. It could be even larger than that. And as we all know, the entire information and data infrastructure, what we have in US, this root name servers, majority are there in US only. So the entire traffic of the world actually passing through that. Entire internet traffic is passing through US. So they have a great advantage if they want to carry out information warfare. I hope you have heard about Operation Prism, where it was revealed, it got leaked out that US National Security Advisor, NSA agency, National Security Agency, had forced many top multinationals like Facebook, like Apple and others, to pass the traffic which was being handled by them through their NSA filters. So we don't know whatever traffic is happening on internet, it still could uh, be passed through the filters of Big Ben. Because most of the IT companies are in US, so they have control over them. Russia has its own capability. Russia has multiple agencies. Some are civilian, some are clandestine, some are military, and there are criminal gangs being used for the state. They are allowed to operate only because they are helping the state. They have got political banking. China, PLA, that is a People's Liberation Army. They have their, informationalized wars is part and parcel of their doctrine. So they have doctrinized this, and they have doctrinized this in form of 3 forms of warfare: psychology, media, and legal, and an integrated network electronic INW concept. So electronic warriors again very well doctrinized, and they have a strategic support force, PLA SSF, which includes space, cyberspace, and electromagnetic spectrum. They have cyber militias, patriotic hackers, etc., etc. And there are many units which are, partially documented, where they have supposed to be carrying out many cyber attacks, spear phishing attacks, etc., etc. They also have a very well laid out capability, because they have understood, or they have probably progressed very much farther in this information warfare domain. This is there again one of the organizations which we talked about. I will also talk about cyber criminals and terrorists. So this presence on the net has increased substantially. Today, all the terrorists and insurgent organizations are using the internet in a very effective way to carry out and conduct their operations, plan them, execute them, etc., etc. For which many of them are using the dark web, or also called the deep web by some. And this is of course a little old. ISIS, whenever it was in full force, they were taking full advantage of the darkest corners of the internet. They were using deep web in a dark web in a major way, using browsers like Tor, the Onion router, etc., etc. So this is again an example of ransomware. You all know. So if you are affected by ransomware, you send a message, your computer will get a message that please pay in bitcoins or something, and you will get unlocked. This is that WannaCry. How the screen used to look when your computer is affected by this ransomware. Again, terrorists using the net. I'll just move forward. So one of the networks was recent business network, again part of the dark web, which was used by various criminals, terrorists, child pornography, online pharmacy, fake medicine, etc., etc. Of course, this has been banned now, but it was suspected that during this Estonia and Georgia operations, this was used to support the state. Steganography, again, a very effective means of communications or encryption used on the net. Even if somebody is trying to eavesdrop on the network traffic, using steganography, they are able to hide the messages, and this information is possible. These are some of the elements of information warfare. Again, use of social media in a big way today. Is carrying out psychological warfare, propaganda, narrative setting, narrative countering, recruitment, mobilization by terrorists, not only by terrorists today, but by various other organizations also, which sometimes are not called terrorist organization, but they are also organizations which can create something like a Arab Spring situation, or the situation what we see in Bangladesh. So mobilizing civil protest, then stone pelting. This was again very effective in about 10-15 years back in the valley. And everybody says whenever such incidents happen, what happens is what does government do first thing? Is shut off the internet. Why? because of this reason, because that is the sole and whole sole means of communication. Very, very effective way of communication, which very difficult to decode and decipher what is happening. So that's why what government does is when such situation come in a particular area, they cut off the internet, they switch off the internet so that the propaganda, the false narrative, the narrative building, and the mobilizing of protest doesn't take place. Cyber war, cyber terrorism, again, all these things are happening on social media. Anyway, let's move. Now, this is a one guy, 17-year-old Graham Clark of Tampa. This is about 3 years back, I think. High-profile hack accounts were hacked of people like Jeff Bezos, Warren Buffett, Bill Gates, and all that. 17-year-old could do that. So that is the power of cyber war. If this thing can happen, it can happen to any one of us. Now, I will not cover this because of security reasons in a very big way, but all I can say is that we need to focus on this. We need to have a proper IW doctrine, cyber doctrine, better coordination of agencies. We need a cyber command, and we need to build all these communities if you want to be part and parcel of this cyber warfare. Okay, and you are involved. Every citizen is information soldier. If you are not cyber aware, if you are not information aware, there could be personal war, there could be embarrassment. You can be tricked into becoming zombie, botnet, or anything. Another aspect I would like to bring out that very recently, just 2 days back, I think, the Data Protection Act draft, Personal Data Protection Act, has been circulated by the government. Now, this, I believe, I have also not read the complete draft, but I believe that there are some very, very interesting, very, very, revolutionary concepts that have been included. That would mean that if your involvement, either through WhatsApp or any other social media, in even passing a fake narrative, deep fake, or something which could be offensive, just forwarding it could get you into trouble. So everybody is now involved. You all have part and parcel of WhatsApp University, what they call. You keep getting so many videos, forwards, texts, deep fakes, and you don't know whether they're true, they're false, they are forwarded to you with a purpose. You may also be targeted because you are considered to be ideologically inclined towards one side, towards the other side, and inadvertently, innocently, you may even forward that and become part and parcel of that ecosystem. And you can now, be caught and tried for that. This could become a cyber crime. This could become a crime against society also. So you have to be extremely careful. You have to be extremely careful and not become a forward soldier. I call it forward soldier. The soldier who keeps forwarding somebody else's, messages. Do not get involved in it. Verify authenticity. If you cannot verify authenticity, just think it is not authentic. It is fake. It is not right thing. Okay. Responsible behavior on social media, very, very important. And all the students must also be taught about this. Again, as I said, ensure cyber hygiene of your own devices. You can, if you don't ensure cyber hygiene, somebody is going to hack it. Even if there is nothing, you think there is no information, you can become a zombie. Your machine can be converted into a zombie and used to transmit deep, so many things, including something which could be harmful for the nation. Avoid become a center forward on WhatsApp, as I said, forward soldier. Be very careful about your privacy settings, responsible use of cyber media, report incidents. Whenever there is incidents, now there is a reporting mechanism available. Go on the internet, you'll find there is a cyber cell in each district, in each police district, and you can log on and forward this information or lodge a complaint wherever is when you think you have been hacked or you have been duped or there is a cyber crime or there is a attempt at a cyber crime also. So this is again a very simple mechanism of cyber security. Protect your network, user education and awareness, malware prevention, use genuine software, use proper antiviruses or other protection mechanism. As far as possible, do not use unprotected removable media, that is pen drives, removable disks and all that. Please ensure they are properly protected. As far as possible, do not use them. Secure your configurations, your user privileges, be very careful, especially when these privileges are related to your social media. We use only default. Go into it, add security layers wherever possible, whether it is you're using Google, Gmail, or social media, etc. Whenever there is an incident, report it to the next authority and to the authorities such as CERT-in or CERT. Nowadays there is a CERT of every state government. Establish a monitoring strategy and ensure your when you're working on any device, electronic device or digital device, be very, very careful what you are using and how you're using that. Password policy, we all know. Again, a very important aspect of cybersecurity. I just picked up some portions from the SOPs, the standing operator procedures being used by in which we will find in CERT-in also. Some of the references which I have used. Okay, I think I have tried to finish it a little early so that we can have sharing of information from some of the very learned faculty who have joined this FDP, as also the other experts who are with us. And let us have some interaction. I have stopped sharing.
Yeah, participants, any questions?
Questions or even suggestions, or you can contribute in whatever I have said. Yeah, I would like to tell you there are some very recent incidents also in information warfare, which I may not have mentioned. So, of course, Ukraine war, we have talked a lot about it. So, both sides have been using disinformation campaign or campaigns to, set a narrative in this particular war. And, though Russia is shown as an invader, or it was probably an invader from the Western point of view, Russia is able to successfully maintain its own information campaign, especially among many countries, that they were forced into this by the stance taken by the NATO and the US. So this is again an information, true, false, we don't know, but this campaign has also been successful. Then of course that election campaign, Iranian cyber attacks on its adversaries. In April 23, they launched a massive cyber attack targeting systems of Russian Israeli companies and government agencies. And we all discussed about the counter attack by the Israeli agencies also. So both sides in any combat situation, any conflict situation, are using huge amount of cyber or information warfare capabilities. And of course, of late, artificial intelligence, generative AI, deep fakes, automated misinformation is now gaining a very, very important position in this whole information warfare scenario. In September 23, United States have come out with a new national cybersecurity strategy, which is focusing on again combating. Now you see the shift in all these strategies. Earlier strategies were related to how to carry out a defense of cyber attacks, how to conduct a cyber attack. But today, a lot of focus is on misinformation, disinformation, deep fakes, etc. Because that is something which is more into cognitive domain. So amongst this, the three domains I discussed earlier, physical domain was important, or to certain extent, information subdomain was important. But today, cognitive has started, becoming more critical as far as information warfare is concerned. Okay. Anybody else?
Yes. Any
I know
questions
it's
from the participants?
late in the evening, and maybe a little tired. The brains are a little tired, but certainly we have about 10 minutes. We can, discuss any issue. Can I see some hands raised? No.
No, sir.
Either
Okay.
I have been very effective or I have been very boring. One of the two.
No, sir. It
Okay.
was very effective session.
No, I think we'll give 5 more minutes and people are thinking.
Yeah. So we are getting feedback in the chat box that wonderful session and
Okay.
Mm.
Yeah, okay, then leave the chat. Thank you. So Madan Kumar. Please give your comments also in the chat box. So that will help us improve when we conduct similar sessions next time. Thank you. Mr. Pawani, Pradeep Gaidani, Dr. Hemant Warkad, Dr. Shivaji Rao Lahane. Okay, Dr. Sagar, I think there is
Yeah.
really we are
Then-
very late in the evening, and
Yeah, we can see a lot of appreciations in the chat box.
mhm.
Yeah. So
Because
I would like to.
this is an area where not many academicians would have really done much of research. So I would also request that please read through it, and a lot of research is required in this field also, especially cyber warfare, cyber security, defensive cyber, cryptography, cryptanalysis. It's a huge scope.
Yes, sir.
Thank you.
Agreed. Yeah, so I'd like to extend our heartfelt thanks for delivering such a insightful and engaging talk on information warfare. So your discussion covered a wide spectrum of critical areas, like you started with domains across various generations, the fundamentals of information warfare, and its evolving domains across these generations. What are different cyber operations from around the world, highlighting real world scenarios, the components of information warfare, and various forms of cyber attacks. And right now, how India is positioning in these areas, its neighbors in the context of information warfare. And you very well suggested what is the role of common citizen in combating the cyber threats, the darknet's role in malicious activities that is happening currently, the role of signography and use of social media. So all of them, I hope the participants really liked it and they enjoy, and probably they will engage those in their day-to-day life. Yeah. So thank you so much, sir, for delivering a wonderful session.
Thank you. I think shall I leave?
Yeah. Yes, sir.
Can leave. Okay. Thank you.
Participants, I have posted the attendance and feedback link for the second session in the WhatsApp group. Please fill the attendance and give the feedback for second session speaker. And now hereby I conclude that both the sessions are over and you can take a leave from this meeting. We will meet again tomorrow at same schedule, 6 p.m. Thank you.
Thank you, sir.
Thank you.